Good morning, ladies and gentlemen. Good morning to all participants as well as our today's presenters. This is our, this year's seventh or eighth webinar. Last month we had three webinars. January we had some webinars, and today we are going to have an interesting subject. But before starting, we have a small, remembrance, a 1 minute silence because one of our very well supporter, the president of our Kerala chapter, Mr. Rajan Menon's son, he passed away in an accident a few days back. On his remembrance, we will probably make a 1 minute silence and then we will start back. Now, let's start the program. So today, we are going to have a webinar on a very interesting subject, which is residual current devices. What are they? How do they work? And what kind of devices are there? Before starting this, we would like to introduce NFE to you. As all of you are aware, we are a registered society, registered
I
in
think
Chennai.
there is some feedback from some of the people saying they can't hear you. I can hear you, but I just want to make sure that others can hear you.
Probably then that is their problem. In the internet, if the participants, if your internet is not very good, sometime you are unable to hear the voice. So please check your internet connections. So we are basically NFE. We are a registered society, a society made for everybody, those who are interested in electrical safety, and to improve the safety situation in the country and to develop skills of electrical or practicing engineers or practicing technicians. So our prime motto is to create awareness. We are conducting a lot of awareness programs. We are also trying to fight a little bit against the wrong practices which is prevailing in the country. I'm sure most of you are the members, those who are already in NFE, they are aware about what we are doing. We have a vision. Our vision is to make Bharat electrically safe, and our mission is to achieve the vision through continuous trainings, skill developments, and empowering people to do a job based on the most modern techniques. As all of you know, we are continuously educating the market weekly. Every week we have the webinar. Parallelly, we also have in-house seminars for the industry. We also go to the institutions such as engineering colleges and conduct some programs. A lot of members of NFE are carrying these messages. They go to the engineering colleges of their respective region and conducting multiple programs. So we basically are trying to build a culture of electrical safety in the country. Even though we call us National Federation of Engineers for Electrical Safety, our membership is not restricted alone. Anybody, those who are interested in electrical safety, can become a member. We have a membership. If we go to our website, you can find out the links for becoming a member. We have membership, individual, corporate, MSME, and so on. So we request you to become member, to participate in several of our activities, which will be very much useful for you to improve your knowledge and skills. So today the subject is about the RCDs, the residual current device. which probably you must have noticed that yesterday we put a poster which say, what is this ELCB? Unfortunately, in our country, the name which we still use is ELCB, which is a device, practically current operated ELCBs are no more available in the market and nobody manufactures it. But still we use the name ELCB, which is, anyway, the speakers will give you very good idea on what exactly we are going to do. We have, as all of you know me very well, we have Mr. Gerard Jansen, the head of international sales in Dobke, Germany. Dobke is a world leader in the manufacturing of DIN rail mounted protective devices such as MCBs, RCCBs, and so on. So very, very good products, very well established company in Germany, very well reputed company, and the products are extremely good. So Mr. Gerard will give us the details about RCCBs. Also, we have our speaker, Mr. Krish. Krish, most of you knows very well. He is the youngest electrical designer in India. He is a member in the IC committees, some of the IC committees, TC64, MT1 and MT12. He is also very actively participating in our BIS ETD 20 and ETD 50 committees. He's an expert in the IEC 60364 electrical installation standard. So Krish also will be speaking today. But before going into the presentation, I would like to make a very small introduction of what exactly is ELCB, especially the current operated ELCB. There are current operated circuit residual current devices as well as voltage operated. Now I am showing you the current operated devices. Let me explain how is this particular the circuit, how to read it. You can see that there is a source. On the left side, there is a transformer, the windings, the three-phase windings, the neutral is earthed. Then there is the phase and the neutral comes to the equipment, probably through a main distribution board, sub-distribution board, probably to a final equipment. Now the equipment body is connected to a PE conductor and finally to an earth electrode. This is a typical, a small example of electrical installation. In case of a fault in the equipment where I'm moving the cursor, you can see there is a fault or there is a leakage in this particular equipment. The current will flow through the PE conductor, through the earth electrode, through the general mass of earth, through the neutral earthing of the transformer, it goes back to the source. So basically, there is a current flow through the PE conductor. And the current flow through the PE conductor is measured in an ELCB, earth leakage circuit breaker. The name earth leakage means there is a leakage which is going to the earth through the PE conductor. That leakage current is measured and this measurement is connected to a mechanical device. Then there is a set current, let's say for example 30 milliampere. Once when the leakage current is more than 30 milliampere, the mechanical device disconnect the supply. As a result, the leakage current or the fault current is also stopped. So basically, the current through the PE conductor, protective earth conductor, is measured in an ELCB and the device is disconnected. So the measurement of this particular current is very critical in an ELCB. As I already told, current operated ELCBs are no more available in the market. Nobody, it's not recommended in the standard. Now, the problem of ELCB is, imagine you have a wrong connection. Your equipment, instead of you are measuring the leakage current in one of the PE conductor, and if you have one more connection, the ELCB will malfunction. It won't function properly. It won't do its desired job. Similarly, the next biggest subject which you should always consider is ELCBs require a connection to the earth electrode. If there is no earth electrode both at the consumer premise as well as at the source for the fault current to flow, ELCBs won't work because there is no current flow. If there is no earth electrode, there is no current flow through the PE conductor. As a result, the body of the equipment will be energized, and if somebody touches at that particular time, people get shocked. So in an ELCB, it's a current operated, I'm talking about current operated ELCB. Krish will explain about voltage operated ELCB. In a current operated ELCB, the leakage current through the PE conductor is measured. That means there should be a PE conductor and there should be a proper earth electrode. So this is a very small introduction about the ELCB. Now I would like to stop the presentation. I would like to invite the today's speakers to take over. First, Krish will start with his presentation, followed by Mr. Gerard. Over to you, Krish.
Yeah, hi, thank you. The screen is visible, right?
Yes.
Okay, perfect. So, good morning, everybody. Gerard will be the main speaker because he's an expert on this subject, but I'll give you a brief introduction. See, I want to illustrate that ELCBs are not available in the market. It's very important that we recognize this because very often, when we've gone to so many places across the country doing our events, and everywhere the term ELCB is being used instead of the term RCD. And I want to illustrate that actually we are not using ELCBs anywhere. You see, I have this picture here, and this picture shows you what an ELCB actually looks like. I mean, we don't use anything like this today. Do we? There is an incoming line and neutral, and there is an earth conductor also in the circuit breaker. This is a very old device that is no longer used in the market today. There are two types of ELCBs, voltage operated and current operated. Mr. Gopakumar has already explained the current operated. See, it's very important to understand how these work. See, how they work is that you have a supply, a load, the ELCB, and there is a coil inside the ELCB connected to an earth electrode. The P connector goes through the ELCB. So there's an in and an out. That's why over here, there is an in terminal and an out terminal as well for the earth conductor. What happens is, if you have an insulation fault, then you have current flowing through the body of the equipment back to the source. It will be through a person touching the equipment and to the PE conductor. But now what happens is, because you have current that flows through this coil, there is a voltage drop created in this coil, and then that causes subsequent disconnection of the circuit. However, if for some reason there is an interrupted PE conductor, or the person is going and touching the line conductor directly, there is no voltage drop created in this coil because there is no current flowing through the PE conductor at all, which is why an ELCB cannot work here. This is why we do not use ELCBs anymore, and they are no longer available in the market. So next time you see a poster like this, shock safety, ELCB, electric shock and earth protection with bypass switch, please realize that this is extremely non-standard. Firstly, ELCB is no longer available in the market. Secondly, how can you have a ELCB with a bypass switch? Because the bypass switch, it defeats the very purpose of the device. And only one unit for a whole house. You will see how this is complete nonsense. We can see here that in several places, this ELCB with bypass has become very common, which is a highly dangerous thing. I don't know how this is ISI marked because this product is not complying to any BIS standard or IEC standard. But you can see many places this is a very common product. This is an example. There was a tailoring workshop where somebody used this ELCB with bypass switch. You can see the protective conductor was interrupted here, and the person actually died. This is a very serious issue. Somebody died because the wrong product was used and the wrong installation practice was used. This is very important. As you will understand, one unit for whole house is complete nonsense. This is because every piece of equipment has inherent leakage currents. This is a laptop power supply. You can see the symbol over here. This is class 2 functionally earthed. The equipment will have some inherent leakage. Mr. Gerard will explain this in his slides. You can see here I've measured 2.4 milliamps on a particular piece of equipment and 10.3 milliamps on a circuit. So it's very normal for equipment to have inherent leakage current. And this is current that cannot be avoided. So if you put one ELCB for entire house or one RCB for entire house, that will cause nuisance tripping. And now when it comes to the type of RCDs, see, everywhere we are using type AC. This is a picture from a luxury hotel in India. And you can see they are all using type AC. Anyways, before I hand it off to Gerard, I will say that, see, whenever we have an electrical installation, we aim for it to be safe, hopefully. We want it to be usable. Obviously, this is in India. Everybody says chalta hai. And we want it to be cheap. Let's face it, everybody wants it as cheap as possible. I am here to tell you, you cannot get an installation that is safe, usable, and cheap. It's not possible. We can have an installation that's usable and cheap. This is most installations in India, but the installation is simply not safe. We can also have an installation that is safe and cheap. You can take one type B RCD, put it on the entire building. The moment you turn some electronic equipment on, the RCD will trip. They're perfectly safe, but you have no electricity to use, so the installation is completely unusable. Where we need to be is safe and usable. I'll end this by saying, if you think safety is expensive, try an accident. It's really not. From this incident here, you can see that if you use the wrong device, you use the wrong installation practice, people die. Unfortunately, in our country, the value of human life is very cheap. It's a very sad state of affairs, but that's what NFE is hoping to change. Anyways, I will hand off to Gerard here. So thank you.
Yes, thank you, Krish. Welcome, Mr. Gerard, to have your presentation. Probably you can share the screen.
Yes, good morning, ladies and gentlemen. Thank you very much. Let me share the screen, just a second. Oh.
Yes, now on the full screen.
Is it visible?
It's visible now, full screen.
Yeah.
Perfect.
Yeah.
You can go.
Okay, good morning, ladies and gentlemen. Yeah, Mr. Krish and Mr. Kumar already explained it a bit, and thank you for the pre-work for me to giving me a short introduction as well. Yeah, first slide does not give you too much at the moment, but my name is Gerhard Jansen. I'm responsible for the sales at a company called Döpke Schaltgeräte. And today we will bring you some information about RCDs or RCCBs, residual current circuit breakers, or residual current devices. Small agenda, who are we, who is Döpke, who is our special expert in India, who is our partner in India, what kind of devices are existing, RCD devices, what are the requirements, what are the different RCCBs, what, for example, is a special type B RCD version, how to prevent unwanted tripping, what about fire protection, and special products for those kind of applications. Yeah, let me start with Döpke, a very small introduction. Döpke is a German company based in the very northwestern part of Germany, shown here on the map. I don't know how to use the cursor exactly. Can you see it? No.
Yeah, we can see it. If you look at the bottom, you can see there's a at the bottom of the screen, left side. Yeah, that one. Yes.
Oh, yes.
That, yes. Then you at the
Okay.
laser.
Yes, thank you very much. So we are located in Germany, very northwestern part of Germany, around 2 hours away from Hamburg. And our products are made in Germany. So Döpke was one of the first inventors of RCCBs in the 1950s. Together with two other companies at the same time, we were the first bringing RCCBs to the market. And we are still, this is still our main field where we're doing our business. The other ones, meanwhile, have gone up into huge companies like Eaton or Schneider, but Döpke is still the independent producer expert for RCCBs in the market.
Suddenly your voice has gone down very much.
Okay. Let me check here. Sorry about that.
It's fine now.
Yeah, okay. So we were one of the first RCCB producers in the world, and this is still our expertise at the moment. We have the widest range of RCCBs on the market, with around 3,000 different RCCBs, which we are also producing for the other big companies, which are available sometimes on the market. So they rely on us for very special products, which we produce with their name on it. We are not the biggest ones, but we have a kind of name to be expert for this. So that was a bit to the company itself. In India, our partner, our specialist working together with us, supplying our parts, is the company B in Mumbai. Mr. Vishal is the expert for you to help if it goes into stock applications, or if you need any help, just get in contact with the guys. They are most welcome to help you here with our products and with technique. Yeah, starting with the technique, the overall topic is RCDs, residual current devices, which are then split up into different devices: RCCBs, residual current circuit breakers; RCBOs, residual current circuit breakers with overcurrent protection; CBRs, circuit breakers, also with residual current protection; and MRCDs on the right side, which are monitoring devices, monitoring residual currents. Starting with the RCCBs, residual current circuit breakers. Those have no overcurrent protection, but let's say only to prevent, have the fault protection. Those RCCBs provide protection against electric shock and fire. That means also they can provide human protection, personal protection, with around 30 milliamp residual current. The product standards in India and also the IEC standard correspond a bit. You see them here at second bullet point. And as in the first introduction by Mr. Kumar and also Krish, we are talking about devices who are detecting if a current or a fault current in a system, in a three-phase system, is unequal zero. So all the currents going into a circuit and coming out of it have to be zero, and the RCCB is measuring this value. And if it's not at zero, the RCCD will trip at a certain value. It's a mechanical or electromechanical device, and it prevents you against electric shock and fire.
Actually, Gerard, the audio is fluctuating quite a bit. I'll just tell you how to fix it. At the bottom right of your screen, you see the mic, right?
Yeah.
Just click on audio, click on the little arrow, click on audio settings.
I have to go out of my presentation. Sorry. I cannot see it at the moment when I'm
you see the Zoom screen, right? If you open the Zoom app?
Yeah. Yes.
There is a little microphone on the bottom left, right?
No, not to be seen when I'm presenting.
No, but now do you see it? When you if you open the Zoom app specifically?
If you unshare, then you'll be able to see.
If you unshare, you can probably just unshare your screen for a moment.
Yeah.
Okay. Yeah, now you see the little arrow on top of the mic. Click on that.
Yeah.
Then audio settings.
Yeah.
And there will be a automatically adjust microphone volume checkbox.
Yeah, it is.
Just uncheck that.
Uncheck it. Okay. Yeah. I did. Okay. Let's see. Let's see if it works out. Thank you very much. Not familiar with Zoom so much. Sorry.
No worries.
So let me share the screen again. You can see it again, yes?
Yes.
Perfect. Okay, thank you. That was RCCBs. Coming to RCBOs, which is a kind of combination of residual current circuit breaker with integral overcurrent protection. That means line protection. So it's a combination of both. Again, to provide protection against electric shock, fire, but as well overcurrent. And the main purpose is to save space. So you can put into a cabinet RCDs and MCDs on a separate wise, like shown on the left side. But if you combine it in an RCBOs as a compact device, you will save space. So 1+ neutral also available, but also 3+ neutral available to save space and to split up circuits, for example. You will see it afterwards in a different slide. So the product standards are shown as well. So there are the Indian standards, your Indian standards, corresponding to the IEC standards as well. The third product to be mentioned are circuit breakers with a residual current trip. And the application is if we have currents greater than 125 amp, those, let's say, big breakers do the same job like the ones before, provide against electric shock, fire, and overcurrent, but up to 250 amps. And the main application for us as experience are MRI scanners all over the world, and as well construction sites. For example, the company Philips recommended some of those breakers for their MRI scanners in around the world. The last device group, let's say, are monitoring devices. One of the newest products, I would say, on the market. So with those products, you are able to monitor residual currents. And if you would like, you can also shut the system, or let's trip it with a different device. But the main purpose is to monitor residual currents, again, to provide protection against electric shock and fire, but monitor before switching. So if you do not want to switch because the machinery is not able to switch down because the whole production process might end up in a mess, you are able to see residual currents arising in a system, being able to have predictive maintenance, send somebody out before the RCCB or the device has to trip because of risk situations. So monitoring devices as well available. You can put them into your whole system via PoE, Power over Ethernet, for example, to integrate it into your SCADA systems. So yeah, to get it a bit more digital in today's world. Yeah, what are the requirements put up to an RCCB? The main requirement is fault protection. And if you have the different RCCBs with different tripping characteristics and tripping residual current tripping thresholds, if we exceed 300 milliamp of residual current, there's only fault protection guaranteed. There is no fire protection or even more being available with such a device. To have fire protection, you need an RCD with at least 300 milliamp of residual current threshold, or better 100 milliamp residual current threshold. If you have to like to have or need more protection, if you need human protection, personal protection as we call it, you need at least 30 milliamp residual current protection in a device. Better go for 10 milliamp. If you have spa arenas or jacuzzis, for example, where water is involved, a 10 milliamp RCD makes the most of sense to protect you and your beloved ones against electric shock. When we come to the history of RCDs, everything corresponds to the presence of DC components in the different systems. So the classification according to presence of DC components and frequencies other than the rated frequency. We are starting with an RCD type AC, which is the most common one, still, I would say, in all of the world. I think as well in India, but as well in Europe and in kind of parts of Australia. So AC is the main product still being used. It's capable of the detection of AC residual currents at main frequency 50 cycles, for example. This is stated in the Indian standards, but as well in the IEC standards. but the AC type is very limited. It's only to detect AC residual currents. And in today's world, where we have completely different loads, not the standard loads from the past, the AC type is not the best selection anymore. So to have higher protection, at least the type A should be used. The type A as well is able to detect AC residual currents, but as well, additionally, pulsating DC currents at the main frequency 50 cycles. So the type AC is not state of the art anymore. In Germany, it's not allowed to use it anymore since 1982. In a lot of different countries as well, it's banned, but it's still existing in a lot of European countries as well, but it's not the best detection anymore. So type A should be the minimum requirement on the market to have at least a bit more protection. The next type to have even additional protection, additionally to AC and DC currents, is a type F, which is also covering different frequency components, unequal 50 cycles. So if you have meanwhile applications or loads where one phase or single phase frequency converters are involved, you will see it afterwards, then a type F should be the minimum requirement. And all of our new modern households have a lot of those applications inside of it. So type F should be as well interesting. But if it comes to industrial protection or industrial applications with three-phase loads, the next RCD category is coming into account. It's called type B. So it's as well capable of A, AC, and F residual current. But the main thing for type B RCCBs is that it's capable of smooth DC residual currents or direct DC residual currents. So that is the one and all best solution for, let's say, to detect each and every kind of residual current. In Germany, we even call it all current protection. It's not the right translation, I know that, but it's known as that. Meanwhile, coming to type A again, so we will spare the AC part of it because we meanwhile think it as being not the safest anymore, and we should switch to type A RCDs. So applications for type A RCDs, as per your SP30, RCDs of type A shall be used where the application may create pulsating DC currents. So also as per the IEC standard, the tripping is ensured for residual pulsating DC currents and for the residual...
Just to interrupt, just so, to people who don't know, SP30 is the official declaration for National Electrical Code. So whenever SP30 is mentioned, that's the National Electrical Code.
Okay, yeah, thank you very much. So as per the electrical code, type A RCDs ensure tripping for residual pulsating DC currents and for residual pulsating DC currents superimposed on smooth direct DC currents, but only up to 6 milliamp of direct DC currents. If we exceed the 6 milliamp threshold DC, then the type A is meanwhile not in the range anymore. You will see it afterwards in some of the other slides. What are the limitations of type A RCDs? They are not able to protect where smooth DC currents, smooth DC residual currents exceed the 6 milliamp DC threshold. For example, if you have electrical charging equipment, which is coming up more and more on the market, it is also not able, it cannot protect where composite residual currents may exist. So single phase variable frequency drives. In a household, it may be a washing machine or a huge drilling machine or something like that. And it also cannot protect where residual sinusoidal alternating currents up to 1 megahertz may exist. So if there are VFDs, multiple frequency drives involved, also then an A-type is not able to detect all the residual currents anymore. So, and additionally to that, as per the IEC 61140, pluggable equipment or electrical equipment with rated current over 4 kVA shall be designed to have protective conductor current with a smooth superimposed DC current component limited to those 6 milliamps. So the threshold should be equal or below 6 milliamp, because otherwise a type B should be used. If you take a socket with 16 amp load, for example, then you will go on to the threshold of this 4 kVA. So sockets with more than 16 amp loads would require not a type A, but meanwhile a type B. But for standard sockets, for example, a type A is the best solution on the market. Yeah, coming back to, I explained a bit already, coming back to applications for type F RCDs, as per the electrical code, the RCDs of type F shall be used for circuits where the risk of residual currents is meanwhile containing DC components. Coming out of those single-phase frequency drives like washing machines, vacuum cleaners, here as well air conditionings. In Germany, the counterpart is meanwhile a heat pump coming up more and more on the market. So we are talking about one-phase plus neutral applications with DC components in it, which every normal modern household will show up meanwhile, or present meanwhile. So the tripping is ensured for composite residual currents, and also for direct DC currents superimposed on smooth direct currents for a type F on 10 milliamp DC. That is a bit different than to the RCDs where it's only 6 milliamp, but for F RCDs it's 10 milliamp threshold direct DC current. What are the limitations of F RCDs? It is not able to protect smooth direct DC currents exceeding 10 milliamp, again charging equipment, for example, or where you have it cannot protect where residual sinusoidal alternating currents go up to 1 megahertz. So if frequency drives, VFDs, are involved, then again a type F is not the best solution. Then you would need a type B. Coming to type B, what are the applications for type B? In general, we can say all three-phase loads or three-phase applications where direct DC currents can occur would need a type B RCCB. This is described in a lot of standards, meanwhile, in the Indian standard as well in the IEC standards, but a lot of markets still at the moment not using it properly. So we have to educate the people still to use that kind of RCDs type B in the application to be on the safe side. Again, as Chris said, it will not be the cheapest solution, but it will be the safest solution. And this is sometimes the counterpart of it. Cheap and safety does sometimes not go align with it. But to have safest protection against fire risk and even the protection of humans can be done with a type B. So RCDs of type B shall be used in case where the application may create smooth DC or direct DC residual currents or contain frequencies higher than the normal 50 cycles grid or 50 cycles. So keep in mind three-phase applications with frequency drives, direct DC currents, or where the normal frequencies are unequal 50 cycles. yeah, to ensure or to explain a bit where the tripping is ensured. With the type B, it is A, AC, F types. Yeah, residual direct currents, which may result from rectifying circuits. Also, application with 2-pulse bridge connections, line to line, for 2, 3, and 4-pole devices. But additionally, as well, the 3-pulse star connection or 6-pulse bridge connection. All those applications, you are safe on the safe side with a Type B RCCB. You see already on the right side some of the applications. Those are solar, photovoltaic, or charging stations. Yeah, specific locations requiring a Type B RCCBs. So inverters, battery backup systems, UPS systems, also as per your national standard code, VFD drives, if you have escalators, lift applications, crane installations with big motors being driven by VFDs, and also the whole big story of electrical vehicles, supply for electrical vehicles, often requires a Type B RCCB to be protected against direct DC currents, which can arise from those charging points. Solar photovoltaic systems, meanwhile, is a application growing in a lot of markets, but very often being installed without the proper protection, which is in the best cases the Type B RCCB. Yeah, why Type B RCCB or why Type B RCD? Where do DC residual currents occur? So this is the standard, let's say, description. You have a 3-phase load, 3 lines, and the earth, and you have a frequency converter involved into the whole system, which is giving us mostly the problems of direct DC currents. This was one of the applications where Type B RCDs have been found out in the history. There was a construction site on a German German construction site. There was a big crane installed. The motor was driven by a VFD, and they had an electrical shock accident. And in the beginning of or the end of 1990s, they were not able to detect why this happened because there was an RCD installed, Type A. So everybody was thinking to be safe, but after checking out the whole system, they found out the direct DC currents being the source of the electric shock. So we have different scenarios. If we take an insulation fault at a frequency converter input, like shown here, as the red one, if it's at the frequency converter input before the filter, then still an RCD Type A is sufficient for this whole scenario. If we go to the next slide, if the fault is between the frequency converter output and the motor, then meanwhile it's not possible to use an RCD Type A anymore because it will not detect the DC part coming out of the frequency converter. So then with the insulation fault between converter output and motor, Type B is required to cover all the danger. Another scenario is if the insulation fault is in the DC link of the converter, also then direct DC current is involved and the Type A would not be sufficient anymore and the Type B RCD would be needed. Yeah, small overview. Insulation fault between frequency converter output and motor. What are the reasons? Often the motor frequency is at 10 Hertz, or the chopper frequency is giving direct DC currents into the grid of a chopper frequency of 8 kilohertz. So there are many different frequency components involved in those VFD drives. They're superimposed on the residual current. For example, the harmonics on the frequency converter there are different harmonics causing such problems. At 16 kilohertz, 24 kilohertz, 32 kilohertz, Dubke even has a system to visualize those frequency or harmonics in the different frequencies. So you can visualize the different residual current in the system to see what part of the frequency gives you the trouble, gives the breaker the threshold to trip, and how to prevent it. So, as told, an RCD of type A would not detect this frequency composition anymore, and the DC part of the residual current would saturate the electromechanical tripping relay in an A-type RCD, would saturate it magnetically, so that the type A would not detect anything anymore. So the type A RCD would be blinded by those DC parts of the residual currents, and it would just stay on. So the whole system would look like it is okay, but it would not detect anything anymore. Even A-type A-type residual currents or AC-type residual currents would not be detected anymore when the tripping relay or the core from that tripping relay would be magnetically saturated. Yeah, different part or another topic is how to prevent unwanted trippings. So the sum of residual currents downstream of an RCD should not exceed 0.3 times I delta nen, so the residual current of the breaker. And we have already a small possibility here shown how this can be prevented. To use RCBOs for the final circuits to split up the final circuits. So if you look at the pictures here, for example, at the protective conductor, you have different small loads on it, and in the end, those loads would sum up and would bring an RCD to its threshold, to its tripping threshold. Krish explained it already in his text already a bit. If you install an RCD for a whole house, this will give you troubles afterwards. What is the source of the leakage? If we go back to the frequency converter, the source of the leakage is coming from the filtering capacitors, here shown in red. Those will give you the DC components to saturate some of the RCDs type A. Yeah, how to prevent those unwanted trippings? By choosing the right RCDs. So here again, in one sentence, accumulated protective conductor currents and or leakage currents likely to occur during normal operations downstream of an RCD should be less than 0.3 times the rated residual current, so I delta nen of the RCD. So if you have the different rated currents of the equipment you are using, by this rated current, you can easily calculate how the maximum protective conductor current for the frequencies might end up in the end. And you can choose the RCDs on the one hand side out of it, or you can see how many of your equipment may be installed after a special RCCB. Yeah, this is the slide which Krish explained a bit already in his text. So if you take a single RCD for an entire installation or for a single house, here, for example, it's a 30 milliamp RCCD for human or personal protection, you would have the risk of instantaneous trippings. So if you see the different lines downstream of the RCDs, the different lines showing up here, 1, 2, 3, 4, 5, 6, 7, 8, those residual currents and the different lines will sum up in the end. So 15 and 15 would be even enough to trip the 30 milliamp RCD which will trip at least 22 milliamp of residual current. So a whole RCCB for an entire installation is not the best solution if you do not want to have instantaneous trippings. So what other possibilities or what other scenarios do we have? There is a scenario with a different RCCB. So this time it's a 500 milliamp RCCB in the system, showing here. That is better if you compare it to the first scenario with 30 milliamp, but only in regards to instantaneous trippings. So the instantaneous trippings may be reduced because the different lines with their different single residual currents arising may not be enough to trip the RCCB. But on the other hand, which is even more important or more dangerous, is that you have the risk of a shock. With a 500 milliamp RCCD, you're not able to have human protection. So if somebody touches a live wire and you get somewhere a shock of 300 or 500 milliamp, this is giving you serious trouble. So also that is not the solution, to put in an RCCB which may hold and has a different residual current threshold to prevent instantaneous trippings. And on the other side, you will end up with a high shock risk or a very dangerous human risk. So what is the solution to prevent the unwanted tripping and to have as well the right protection, fire protection or human protection? The right way to do is to split up the whole installation. So you have one RCD in the mains, but if you go downstream, you have different RCDs splitting up the different single lines. Here it's 100 milliamp going down to the different lines again, 330 milliamp for human protection. So if you have small sockets which are being worked on from humans, then you should protect it by 30 milliamp. And there is another, for example, with 300 milliamp in a line for to prevent before fires, to prevent fires. So the solution is split up the whole system into different lines with different RCCDs or different versions of RCDs. The next slide is showing a bit the possibility of an MCB. So the on the left side, you see the green, yellow, and orange part of it. So this whole part is covered by an RCD. So 30 milliamp RCDs are required where resistive faults may cause a fire, or 300 milliamp RCDs required in all other cases. So with RCDs, you're able to prevent fires and also prevent electric shocks. If you take an MCB, for example, shown in this tripping curve here, it would not be able to give you fire or human protection. So an MCB is line protection and not in the first case fire and human protection. Yeah, shown here again a bit the different reasons why a fire may occur in special applications. So if you see humid dust or something being on a surface with a enough high current, for example 300 milliamp of residual current for a certain time, if you exceed 60 watts, this will cause a fire after a certain period of time. Speaking about fire protection in BE2 conditions, so what are those applications? So manufacturing, processing, or storage of flammable materials, including presence of dust. Here you have a high risk of fire to occur. So for example, barns, woodworking shops, paper factories, paint shops, all those applications have a high fire risk. where you should use RCCBs to prevent those fires. From our side, Döpke has specialized products for fire protection. Here you see a type B RCCB for special fire protection applications, which are even better than the standard. The standard is going up to a frequency range of 20 kilohertz, and this breaker, for example, is going up to a frequency range of 150 kilohertz. So we are even above the normal or the required standard. The upper tripping limit is 300 milliamp. Tripping curve or tripping threshold, yeah, exceeds the requirement of the standards even in the end. Here you see the tripping curve of a standard type B RCCB, and again you see the threshold of 300 milliamp in regards to the frequency, and if the frequency exceeds, also sometimes the residual current exceeds. With a standard type B RCCB, extra fire protection is not given anymore because we are exceeding the 300 milliamp of residual current. If we go to the next slide, you will see the tripping curve of the special breaker shown before, the BNK type, and you see here it stays in with the tripping curve, it stays in the threshold of 300 milliamp. So that is still the threshold for fires, and the tripping frequency will not go over the 300 milliamp. So keep in mind, we have different type B RCCBs for different applications. If special fire protection is needed, also there is a special type of RCDs available. The guys from BMEC can give you additional informations or can even tell you if they are in stock or not. As I said in the beginning, Döpke is quite known as being a specialist for RCCBs. Even big companies or customers from big companies like ABB and Schneider customers sometimes call us telling us, oh, we've been transferred from ABB or Siemens to you because they could not answer our question. They could not answer our RCCB question. So they sometimes pass on those customers to us to give them the right explanation. And this is also shown in our range. We have 3,000 different RCCBs, and all RCCBs can also done in a special heavy-duty version, which is called HD. So they are made of different materials. So they're extremely resistant to corrosion. They're less sensitive to environmental influences like frost, heat, dust, moisture, or corrosive gases, for example. The latch, the tripping latch, which is underneath here, is made from special stainless steel to avoid corrosion. And it has even an extended temperature range. We are able to go up to an ambient temperature of 70 degrees Celsius. The standard is normally -25 to 40, and with this special HD version, we can cover also applications up to 70 degrees ambient temperature. Yeah, those are the special applications for HD RCCBs. Construction sites with a lot of dust, cold stores with different levels of humidity because of the different temperatures, agricultural locations in regards to corrosive gases in the air, printing and paint shops where you have also corrosive environments, swimming pools and spa areas as well because of the chloride gases. So keep in mind special applications needing special protection HD or heavy duty RCCBs as well may give additional protection. And yeah, yes. This is also part to show where the HD version is being different than a standard type. This is part of the contact apparatus. This is one of the 4 main contacts, and it's made of special material, special plated material, which is more resistant against corrosion. Yeah, giving the circle back to the Indian market, as I said, we are working together with company BMAC in India. Those guys even stock our material, our RCCBs for the different applications, and they have also all kinds of products on the shelf to cover you up for all kinds of faults being in the market. So you see in the chart what kind of protection the different products offer. The blue one is the standard fault protection. The red dot is giving you additional fire protection. And if it comes to human protection, you see that 30 milliamp RCDs are required, 30 milliampere, to have additional protection or human protection on board. So the guys from BMAC stock the material, can help you on the technical side to find out what application might require the right RCCBs. Yeah, final slide. BMAC was the partner who brought our products to the Indian market. We're very happy to have such a good partner in the market, to have the made in Germany products being now ready for the Indian markets. So if there are any questions, just recall to the guys from BMAC. Also, Mr. Krish is technically very sound on those products and can assist you here. Yeah, thank you very much for your time. Please let me know if there are any questions which are occurring now. Then I'm happy to answer that.
Yes, thank you, Gerard, for the nice presentation. It went in depth. So parallelly, there were so many questions in the question Q&A. We request the participants to post your questions in the Q&A, not in the chat box.
Yeah.
So that we can answer. Already there are about 27 questions out of 27. 20 are already answered. If you look at the chat box, you'll be able to see the question as well as the answers.
Oh, yes.
Participants can also look at the chat box. Now we have about 8 questions. Can we take up the questions?
Yes, of course. From my side, of course.
Yes, Krish, the first question. I have, Mr. Abhijit, I have multiple installation from 90s where we have voltage-based ELCBs installed. Every time they try to measure fault loop impedance, they trip. Is fault loop impedance relevant for this product? Is the tripping normal or is sometime wrong with the system? Means for voltage operated ELCB, does the fault loop impedance work?
Yeah, okay. May I answer?
Yes.
So actually, I'll just share the screen again. So Abhijit, actually, it's a good question. See, irregardless of whether it is a voltage operated device, a current operated device, whether it is an RCD or ELCB, when you perform a test for earth fault loop impedance, it can cause a trip. Now, the first thing is if you have an ELCB, please remove it. They're not permitted by the standard anymore. The standard requires you to use a device that conforms to IS 12640 or IC 62423. So there is no option of using an ELCB. Now, what happens when you use a test instrument is that the way it works is it injects a current through the line conductor and the protective conductor. This current will be obviously picked up by the ELCB or RCCB. Now, there are 2 types of settings when you perform a test. There is a low current test and there is a high current test. I'm just seeing if I have an instrument here to show you. No, I don't. The low current test will ensure that the device doesn't trip. the high current test will cause tripping of the device. Now, whether it is different for ELCB versus RCB, I cannot say. Maybe a ELCB has a lower threshold for tripping. But in any case, you should not be using an ELCB. It should be replaced by RCD because standard requires you to use a device conforming to IS 12640 or 62423. There is no option for an ELCB to be used.
Yeah, but Krish, the question is about an installation which is done during 90s. So at that time, probably ELCBs, voltage-based ELCBs may be there. Anyway, I have no idea, I think. Okay, let us go to the, of course, but the question is whether the device will trip. All kind of RCDs will trip if the test current is more. ELCBs, of course, it will trip because we are creating a short between the line and the earth. The device makes a short for few cycles. So there is because open circuit voltage, short circuit current is also measured, so it will trip. Then the second question from Mr. Albert Shager. In our building has three-phase connection having 5 numbers of distribution board, including TPN and the single SPN DBs. Each should place 30 milliampere RCCB, or in main panel only I can fix. That means that the main panel, can I fix one RCCB, or each panel should I fix RCCB? Krish, probably you can answer this.
Sure. Actually, I am just going to pull up Gerard's slides only. So as you can see from the screen, like Gerard showed us, see, if you have single RCC for entire house, if you put 30 milliampere, then it will give you nuisance tripping. If you put 500 milliampere, it will give you prevention of, it will not provide you shock protection, additional protection. But the question here is that what do you need? If you have a TN system, you don't need fault protection from an RCD. You only need additional protection, and if certain cases, fire protection. So you have to sectionalize. My recommendation to you is use an RCD only where it is required. Use an RCD, for example, if you're using a socket outlet, use a 30 milliampere RCD only on the socket outlet. Now, there is some slides about the nuisance tripping. See, I will show you. I have to get my own slides for this. I don't think this has been covered here. But basically, there is a nuisance tripping of RCDs that happens due to the currents in capacitors, like Gerard showed us. Now, I will just show you this where it shows this. Okay. See, the standard says that, the standard says accumulated currents in protective conductors may cause an RCD to operate under non-fault conditions. For example, current developed by SMPSs of multiple computers, or too many computers are connected to a circuit. To avoid such circumstances, proper sectionalizing is necessary. What happens is when you have equipment, they have these filtering capacitors like Gerard showed us. And this causes some amount of current to flow through the earth conductor. If you take a thumb rule of 1.5 milliamps per socket, okay, the standard says you cannot load an RCD to more than 0.3 times I delta M. So 0.3 times 30 is 9 milliamps. So 9 milliamps is the maximum threshold. Now 9 milliamps divided by 1.5 milliamps gives us 6 sockets. Any more than 6 sockets, you will have nuisance tripping. The idea is very simple. We do not want to exceed this value. That is why you need to select RCDs only where required. And if it is required for fault protection, then proper sectionalizing, like the diagram that Gerard showed us, is required. Otherwise, you will have nuisance tripping. It's very simple. Important to realize, if you have the wrong type of RCD selected, let's say you have a type A selected in where a type B was required, or a type AC selected, what happens, like Gerard mentioned, is that the RCD gets saturated and then it will not trip at all. So forget nuisance tripping. So you will think everything is perfectly fine, but in reality, your RCD has got saturated and it cannot trip. That is why the selection of the right type of RCD is extremely important.
Okay, right, Krish. That was a detailed explanation and very good explanation. Now, Mr. Ravi Varma, the question is: my house have three-phase plus neutral power connection. I am using 4-pole RCCB 40 amps 30 milliampere for power load, but only two-phase plus neutral connected in 4-pole RCCB, and for lighting and one more RCCB 2-pole has been used. Actually, the question is not clear, Mr. Ravi Varma. If anybody wanted to have a direct question with us, you can also talk to the speakers. So if you have any question, you can put it or you can raise your hand so that we can allow you to ask the question so that it's more clear for you. The question next, again, Mr. Ravi Verma, 4-pole RCCB has been used only for 2-pole plus neutral. One phase is not connected. What will happen? Krish, the question is, there's a 4-pole RCCB, but only 2-pole, 3 poles are used. What happens?
So this depends on the manufacturer of the RCD. Some manufacturers of RCD, I think Gerard, you can answer this question. Yeah, you are muted.
You're right. This depends a bit on the different RCCBs. So it depends where the neutral is on the RCCB. Some producers have the neutral on the right side. Some have them on the left side, and it depends a bit on the producer. From our side, this would also work. So we have no problems in securing that possibility as well. It depends where the test circuit is being installed in the RCCBs. So from our side, this is covered.
Okay. Okay, thank you, Mr. Gerard. The next question, 1 to 6 milliampere is often termed as let go current, and average let go current is 10.5 and 16 milliampere for women and men. Is it okay to have current setting a range of 30 milliampere? Krish, probably you can answer this.
It's an excellent question. So I'll refer you to the standard ISIC 60479 part 1. Now, the truth is, you're right, these currents are dangerous, but the effect of this current depends on the time you are exposed to the current. Now, the standards clearly says that there's a current time graph. On the x-axis is current, y-axis is time. When you have currents, they are divided, and time exposure, they're divided into 4 zones: AC1, AC2, AC3, and AC4. When you have currents that form in AC1, the shock is imperceptible. The AC2, the shock is perceptible, but there's no muscle reaction. AC3 is the shock is perceptible with muscle reaction. AC4 is your ventricular fibrillation. Ventricular fibrillation is your heart's cardiac rhythm is interrupted, and then you have your heart's rhythm is stopped and your heart stops. We have some experts coming from this, by the way, in September from IEC to talk about this. Anyways, the point is that it depends on the current time. Why 30 milliampere is because aside from the effects of ventricular fibrillation, there is something called muscular contractions. And the standard says that the effects of muscular contractions are either tolerable or non-tolerable. So further division on the graph is the green zone and the red zone. If you have a green zone, you have a tolerable risk of muscular contractions, and the red zone, you have a non-tolerable risk of muscular contractions. When you use a 30 milliampere RCD, as you can see in this blue color line, you are restricting yourself to tolerable risk of muscular contractions. Remember, RCDs cannot limit the amount of current, they can only limit the time. So when you use a 30 milliampere RCD, you're limiting time such that you are having a tolerable risk of muscular contractions and no risk of ventricular fibrillation. That's why 30 milliampere is suitable. Thank you.
Okay, Krish, probably you can answer the next question else as well. We have a specifically draw a line where 30 milliampere RCCB is not to be used. My understanding so far is 100/300 milliampere for industrial use and 30 milliampere for domestic use. Mr. Shailesh, it's wrong. Probably Krish can answer. The question is very simple. The general assumption in the industry is 100 or 300 milliampere is for industrial use and 30 milliampere for domestic. Can you throw light on it?
This is completely wrong. I think Gerard wants to say something.
Yes, this is quite wrong or dangerous. So 30 milliamp is required for human protection. So if there are sockets or whatever where human protection is needed, 30 milliamp RCDs have to be installed. If it goes higher and you do not have the risk for a human to touch a live wire, if it's only about fire risk, for example, then 300 milliamp or 100 milliamp may be enough, but it depends on who is able to touch it or where the risk, for example, is. So 30 milliamp human protection, 300 milliamp fire protection?
Thanks. I'll just show you the requirements in the Indian standard. See, this Indian standard says that 30 milliampere RCD shall provide additional protection for 3 areas. Number 1, if you have a socket outlet up to 32 amperes for use by an ordinary person for general use. So that is any socket outlet in a home, office, factory, etc. up to 32 amperes, it has to be protected by 30 milliampere RCD. If you have mobile equipment for use outdoors like a lawn mower, etc., also required. And a final circuit supplying luminaires, any lighting circuits in a domestic environments also require 30 milliampere RCDs. And any special location, for example, sauna, swimming pool, whatever, there are separate requirements. But normal installations, socket outlets, mobile equipment, and AC final circuit supplying luminaires. Bathroom is also special requirement where 30 milliampere is required. Fire protection says in B2 conditions like Gerard showed us, for final circuits and current using equipment, you need 300 milliamp if there's a resistive fault, 30 milliamp for resistive fault, 300 for other cases. What is a B2 locations? Where you have manufacturing, processing, or storage of flammable material like a barn, woodworking shop, paper factory. Where do you need fault protection? Fault protection is required in 2 cases. In a TN system, if you are not able to meet the Earth's fault impedance requirements. I will not recommend you use an RCD here because if you use an RCD here, there are still other problems that may arise. For example, you may have an intolerable voltage drop or your short circuit impedance will be exceeded and you have an issue with fires. The main reason is in a TT system, you need a RCD to provide fault protection because in a TT system, because there's no metallic fault loop, there's not enough current to cause an MCB to trip in the event of a line to earth fault or a line to exposed conductive part fault. That is when you need an RCD. Here, there is no limit for the threshold. So to blatantly say that 30 milliamp for resident, 100 milliampere for industry, 300 for industry, that's completely wrong. It is completely application dependent.
Okay, right, Krish. That was a detailed explanation. We have Mr. Surendra has raised the hand. Mr. Surendra, your talking is permitted now. Probably you can ask the question directly with the.
Yes, thank you, sir.
If you could introduce yourself, would be good.
Yes, I'm Surendra Salunki, sir. I'm working in a chemical industries, and we have a lot of projects, and all contractors are using the welding machines, cutting machines, all the equipments, extension boards, and we are providing power to them through the ELCBs. Is it it is a right way to protect them from the shock, sir?
You see, first of all, ELCB itself is not available in the market nowadays. It's RCCB. So probably you are not using ELCB, you are using RCCB. Now, to answer the question, probably Krish, you'll be able to answer, or Mr. Gerard?
Gerard, would you like to try? Would you like to answer this question?
The question is, Mr. Surendra, can you explain the question again? Can you?
Sir, we have a lot of projects going on the plant, and all the contractors having the welding machines, cutting and all machines, and when we are providing power to them through the ELCBs only to protect the protection from the electrical shocks. It is the right way to use ELCBs for this work, sir?
Sir, there is no ELCB available in the market. If you are using an ELCB, I highly doubt you're using an ELCB. The device you are using, hold on, I'll share my screen. Does it look like this, the device?
Yes, sir.
So that is an RCCB, not an ELCB. That is an RCCB. Now, the question comes, is it the right way of using? It depends on the equipment. If you're using welding equipment and using RCD, then it has to be a type B because the nature of equipment is very different. It's not, there is no limit on the amount of leakage current. There is no limit on the amount of the nature of leakage current either. So then you need a type B.
Okay, sir.
Okay.
I think, yeah.
So now
Thank you, sir.
Thank you, Mr. Surendra. Then the next question, Mr. Ravichandran, to Mr. Gerard. What do you recommend for selecting RCD in existing installation based on measurements?
I'm not exactly sure what is meant by it. What you meant for the selecting.
So I
Okay,
can,
will we measure the leakage current and put an RCD? Probably, Krish, can you answer this?
yeah, sure. So, Mr. Ravichandran, the thing is, when you, if you want to measure and put an RCD, of course you can do that. But again, remember, it's, you cannot measure. So, for example, the cardinal rule is 0.3 at a time, right? So your residual current, your leakage current of a certain value, that has to be lesser than or equal to 0.3 times the rating of the device. Now, for example, if you have 50 milliampere leakage current on a device, and you work backwards, 50 milliampere divided by 0.3, you get 166 milliampere. So you may say, okay, I want to use a 300 milliampere RCD. The point is, for that application, do you need a 300 milliampere or do you need a 30 milliampere or do you need what rating? So yes, you can do that, but the point is that if you do that, you may not actually meet the requirement of the standard. So then you need to sectionalize. You need to find out where is that leakage coming from, and you need to break them down into multiple final circuits, and then the individual final circuits have to be protected as per the requirement of the standard. So yes, you can do that, but you need to be careful that you still meet the requirement of the standard. Thank you.
Yeah, that actually complicates the system. We have few people raised the hand. Mr. Santosh Deshpande, sir, if you can ask the question.
Yeah,
directly.
good afternoon. Good afternoon. Am I audible?
Yes.
Yeah. It was very nice session. I'm thankful to Mr. Gopakumar. Anyhow, I will come back to my question. It is a specific
Sir, why
question
don't
I
you
have got.
introduce yourself?
I'm Santosh Deshpande. I'm Santosh Deshpande, electrical consultant. I have a few hospitals for designing. And I am worried whether operation theater should be connected through RCD.
No,
Yeah.
for operation theater, you see, medical locations are classified into group 0, group 1, group 2, with respect to the nature of activity which is done. That means, with respect to the where do you apply the applied part of the biomedical equipment. So, group 0 is a location where no applied parts are used. Group 1 is a medical location where applied parts are used outside the skin. Group 2 are locations where applied parts are used internal, inside, bypasses the skin. So, wherever you use vital biomedical equipment, if you use an RCCB, then probably it creates more issue. The recommendation or the mandatory requirement from the standard is to use a medical IT solution, medical IT supply for those locations, so that even if there is a leakage from one or multiple of the equipment, the supply is not, not multiple equipment, one of the equipment, then the supply is not disconnected. So you need to go for a medical IT system for that particular, location. Krish, you would like to add something?
Thank you very much. Thank you very much, sir. Thank you very much.
Yeah. So I'll just show you the excerpt from NEC. See, there are group 1, group 0, group 1 and group 2 locations. Depending on the location, the protective measures are different. For example, if you go back to the stand, if you go back, for example, operating theater is a group 2 location. Whereas, for example, an anesthetic room is also a group 2 location. Group 2 locations, ICU also intensive care room is group 2 location. In group 2 locations, the requirements for electrical installations are completely different. Like Mr. Gopakumar said, you need an IT system. There may be certain group 1 and group 0 locations, group 1 and group 0 location, then you can use an RCD, and then it is a requirement also. So then you need to use the right type of RCD. But group 2, you're not allowed to use an RCD as per the standard, because you cannot have disconnection in an operating theater. That will cause a hazard to the patient. Thank you.
Right. Thank you.
Okay, so thank you very much. Now we will take one question and then come to one question from the Q&A and then come to the next person. Mr. Imran Maulavi, similar to type A RCD, will type AC RCD also get saturated in case of DC pulsating or smooth DC current?
Yes.
Yeah, would you like to speak?
Okay.
Yes, it would be. There would be no difference to a type A RCD. It's well dangerous. Also, the AC RCCB would be saturated.
Okay.
If it exceeds 6 milliamp.
Okay, that means it's extremely dangerous to use type AC RCD in look. Okay, now, Mr. Gerard, I have one question. So I wanted to ask a question. So we often know that several of the countries in Europe don't use AC RCDs anymore, and
Yes.
mostly it is the other types used. Can you throw some light on it? Which are the countries where AC RCDs are probably banned or not allowed to use?
It is definitely Germany. It is definitely the Netherlands. Meanwhile, it is Austria. It is Switzerland. It is Norway. It is Sweden. Still in use, it's in Poland. Czechoslovakia is changing at the moment. So there are some executions. Sometimes they have the chance to get out of it, but they as per the national or as per the IEC standards, it should be harmonized in all of the European countries. Meanwhile, but they have national deviations sometimes. But I would say 80% or 85% of the West European countries are meanwhile going to A or meanwhile have A.
Okay, so that means AC is no more manufactured or sold in the market. You cannot get it.
It is, you can get it, but you have to take the risk on your own. So if somebody is installing it, you have to do a risk assessment. And if you need power from the national power supply or whatever, they will easily take that risk assessment and tell you, oh, this is not enough for us. You will not get power. So in the end, the installer or the engineer who's putting it in the system and doing the risk assessment and setting it on a go is taking the risk from the insurance company.
Okay, I got it. Thank you. So now we have Mr. Srinivasan. Mr. Srinivasan, you can unmute yourself and speak.
Yeah, good afternoon, everybody. Am I audible?
Yes, if you can say a little bit louder.
Yeah, am I audible now?
Yeah.
Yep.
Okay. See, I'm referring to the unbalanced load, and there's a lot of nuisance stripping in an unbalanced load, especially the apartments. I'd like to have some light on that.
Actually, unbalanced load has nothing to do with residual current. Whatever the unbalanced load, it will go through the neutral conductor. Mr. Gerard, you would like to answer something?
Not my real topic, let's say. I think you're more familiar with that.
Yes. So unbalanced load has nothing to do with RCDs. RCD's job is to disconnect the supply only if there is a residual current. In the sense, if there is a current which escapes from the circuit, from all these three-phase wire and the neutral conductor. So practically unbalanced is not a subject for the RCD.
It doesn't matter whether the load is balanced or not. It's only the presence of residual current.
Yes. Thank you. We have Mr. Mallikarjun who has raised the hand. Mr. Mallikarjuna, you can also speak.
Yeah. Good afternoon, sir. And thank you for this knowledgeable session. Thank you, Gopal sir. Thank you, Krish and Gerard. So I have a basic question, a fundamental question. Say, when we use RCBO or RCCBs, which are rated for 230 volts application, can we use this for 110 volts application? Will it work?
For
I mean,
110?
why I'm asking this question is that when we use this test push button to check whether the RCCB or RCBO work for when we connect with 110 volts application, it doesn't function. I mean, that was not working. However, when we consulted the OEMs, they say that no, it works, no problem. But how do we ensure that it works when we use it for 110 volts application, AC application?
I would say it depends as well on the producer of the products again. So we have special 110 volt versions to secure proper working. And the test button for our RCDs is at 50 volts. But we have special RCCBs and RCBOs for 110 volts.
Yeah, I understand. Applicability wise, I mean, availability wise, yes, I agree. You might have 110 volts application, when I use the 230 volts tested product with 110 volts AC, will it function, to meet the requirement of residual current?
It's a little bit complicated question.
The thing is, sir, actually in market, actually it was quite difficult to get 110 volts AC application. For the product which is tested with 110 volts, it has to be imported, they said, and then we have no other option. So we are still using it.
No,
Yeah,
may I answer?
so Mallikarjun, actually, it's in our market, especially the salesman, those who are selling the products, they will claim whatever you ask. Since you asked 110 volt, they will say it will work. If you ask for 60 volt, will it work? Then they will say it will work. There are sometimes the MCB, these companies representative, they say that we came across one case in one of our webinar. The manufacturer's person, he was telling MCB, type B MCB is for rural market and type C MCB is for project market. So, so Krish, you would like to add something?
Yeah. So it's exactly like Gerard said, it depends on the manufacturer. Now, in the case of Doppke, like he said, they have 110 volt models available because they realize that that is a requirement in the market. And their test button is different. But whether or not it will work, unless the device, salespeople will say anything. Unless you have it in from the manufacturer's original documentation that it will work for that voltage, like it is in the case of Doppke, please do not blindly believe what the salesperson is saying.
Yes, I would like to add that you look at the test report for such special things.
Sir, actually, we have consulted their R&D team, and then they have given a document saying that it's a current operated device. So only the test push button doesn't work. However, if you test it, the RCBO works. So what we did is we did a small test in-house with a battery, and then we just passed the current through only one circuit. I mean, one pole. So it operated. So we thought, okay, it may work.
But a battery is not the test instrument. You need an RCD test instrument that conforms to the relevant 61557 series. A battery is not a test instrument. And there is no regulation on the voltage or current there.
Probably for the current through the battery, it worked, but it's not. You're not sure that whether during a shock situation, whether the person is protected or not, which is much more critical.
I would
Anyway.
would rely on the data sheet of the manufacturer. If it says it is working, then I would rely on it. If not, it depends on you, of course, if you like to take the risk.
Yes. Okay. Now we have the next question from Mr. Umesh. Mr. Umesh, you can unmute yourself and ask the question.
So just myself, Umesh Park from NTPC. I just want to add regarding the unbalanced current. Any unbalanced current can be divided into a positive and negative sequence, and it will not affect the performance of RCD. That's why I want to add only.
Okay. Okay, you made an answer saying that the unbalanced load has no influence to the leakage current. Am I correct?
Yes.
Okay, thank you. So now, Mr. Imran, you have raised your hand. You can unmute yourself. You are not audible. Okay, now let me take a question by the time. Mr. Ravi is asking, in earth fault also live conductor have an earthed path. So what difference between leakage and earth fault? So Krish, you can throw some light on leakage fault.
So see, earth fault is current that flows in the event of a fault. I'll just share my screen and you can see on Electropedia the definitions. 1 second, I will just share the screen. See, earth fault current is current flowing to the earth during an insulation fault. I'll just zoom in. Earth fault current is current flowing to earth during an insulation fault. Okay. Whereas earth leakage current is current flowing from live parts of the insulation to the earth in the absence of an insulation fault, because leakage currents are normal, whereas to a value, of course, whereas fault currents happen in the event of a fault. That's the difference. But to an RCD, several components of leakage may look like a fault. That is why the proper sectionalizing is required.
Okay. Good answer. Krish, we have two participants. Mr. Imran, I don't know. Mr. Imran, you can speak.
Am I audible now?
Yes, now it's.
Oh, my question is it mandatory for the equipment manufacturer to keep the leakage current below the values which are shown in IS table, which we are following for designing?
Can you repeat the question?
Is it mandatory for equipment manufacturers to keep their leakage current below a certain value, which was shown in that table in IS? Like
You mean to
suppose
say equipment means the RCCB,
equipment,
or you are
no,
saying
no.
equipment means some electronic equipment?
Electronic equipments which we are using, for which where there is a standard leakage current, light fitting or something, washing machine. So is it mandatory for those manufacturers to keep that leakage current below a certain value?
Very much mandatory. Very much mandatory. You can find it in IS 732. Krish, you have that table probably, if you can.
It was there in the slides itself. I will just share it.
Yeah. So the maximum allowed leakage current from any equipment, irrespective of its current, is 10 milliampere. So the minimum, for example, if you have a device with, let's say, 2 amperes of current, it's about, yeah, this is the one.
Yeah, so the requirement is that depending on the nominal current of the device, there is a certain rating. 0 to 2 amperes, 1 milliamp of leakage current, 2 ampere to 20 amperes, 0.5 milliampere per ampere, anything in excess of 20 ampere, 10 milliampere. Now, there are certain exceptions where for fixed equipment, you can have excess of 10 milliampere, but this shall not exceed 5% of the rated current per phase. On paper, this is a requirement.
So is it followed in India for all equipment manufacturer?
That is very difficult to answer because unfortunately, new products, new devices, often this is met. But due to aging and due to various reasons, sometime after a few years, probably the leakage current is high. Because we don't have the habit of making this insulation resistance test. So even from the fixed wiring also leakage currents are there. So,
Yes,
Mr.
sir.
Ravi,
Thank you.
Hello.
Yeah,
Yes.
ask your question.
Good afternoon, sir. Sir, my name is Ravi Verma. We do residential projects. In one of my apartment, where there are around 400 plus apartments, we have provided each apartment with 63 amps 4-pole 30 milliamps main breakers. What happens randomly? Simultaneously around 10 to 15 flats, RCCBs are getting tripped. When we spoke to the consultant, they come up with the reason like the incoming grid may be having some fluctuations, variation in the power. So it is affecting few flats. I'm not able to find out the cause, sir. Like why out of 400 apartments, few randomly, few apartment RCCBs is getting tripped simultaneously. This because of the source issue, variation in the source power, or because of the load
Most
issue?
often, no. Probably these 10 apartments where the device tripped, the apartment owners must have used some faulty equipment. Krish, you would add some answer?
See, there are some fringe cases where that can happen, but in most cases, it is very simply the fact that they have exceeded the 30% threshold. See, every RCD is designed to trip between 50% and 100% of its rated residual operating current, which means for a 30 milliampere device, it can start to trip at 15 milliamperes. Now, what very often happens, like Gerard showed us, is that people don't follow sectionalizing. For the entire house, they put one RCD. For entire phase, they put one RCD. then what happens is that it's very common for it to trip. The consultant might have just come up with some reason to show that it is out of their control. The truth is that proper sectionalizing is necessary. I'll just show the slides for that again. See, unwanted tripping, if you sectionalize, see here 100 milliampere RCD, downstream, so 100 times 0.3 is 30. So 15 and 15, 30. This is fine. 30 milliampere times 0.3, 9 milliampere. 33395. For this 300 times 0.3 is whatever value that is. But that is.
Yeah. This I understood, sir. When we individually found the flat, when we checking it, we found there was few leakage current, and because of that, it is exceeding that 30 milliamps. It is getting tripped. Our question was like, why it is like a few apartments, 10 apartments simultaneously getting tripped? There is anything connected to input source?
Most cases.
You can unshare.
Yeah.
So what is the RCCB you used? Is it a 30 milliampere RCCB or?
30 milliamps.
And these apartments are already, people are already living in those apartments.
All are occupied. Or that too is not continuously getting tripped. If it is getting tripped, simultaneously it is getting tripped few apartments only. There is a leakage in the flat we found, but any chances like outside of the source voltage or source power supply, because of that variation, this getting tripped, I'm not able to find it.
There are some chances. For example, in case of a fault on the high voltage system, high voltage transformer, there can be some transfer potentials into your low voltage system. This may be because up to 5 seconds, up to 1200, 1300 volt will be applied between the line and the earth in your equipment in case of a TT system. And during that time, probably, the leakage current is more from a few of the connected devices and it can trip. But those chances are very rare. You should check whether at that time, whether any fault happened on the HT side of the transformer. But generally, if there is a fault on the HT side of the transformer, rather than tripping, most of the time your equipment's burned.
So,
You can check. There are chances.
How to
Please perform the insulation resistance measurement on the installation to see if you have any damage.
Oh, that we have checked, sir. So, like, if there is any high voltage variations, there is any equipment to protect it, like not to go to the RCCB, sir, the end user. We can protect it, the panel itself.
Unfortunately, for the transfer potential from high voltage, there is no solution available. Only the electricity supply company. They have to make their supply system, their supply in such a way that the transferred potential is very minimum.
Okay.
As a user, you cannot do, practically, we cannot do anything. So, thank you very much. We have probably Mr. Ravi Devaya. You can unmute yourself and you can speak. Mr. Jackson Sebastian. Also, Mr. Vijay Kumar NM.
Hello, can you hear me, sir?
Yes.
So myself, Vijay Kumar. I have some doubts, sir. What about the harmonics affection in RCD, sir?
Krish, you would like to answer?
This is a very good question, and it comes down to the type of residual current. So if you have harmonics in single phase, it has to be a type F. If you have harmonics in 3-phase, it has to be a type B. And it depends on the manufacturer. For example, like Gerard showed us, depending on the frequency of the harmonic current, the RCD has different tripping characteristics. For it is normally the higher the current, the higher the frequency, the more time the RCD takes to trip. But like he said, there are certain types available where regardless of the frequency, it trips. Now, if you have a type AC or an A RCD here, what happens is that a type AC or A RCD cannot trip correctly in the presence of harmonic current. So you need a type F for single phase applications. If composite residual currents exist, so harmonics and fundamental frequency, which will be most cases, and for 3-phase, type B.
Okay, sir. Thank you.
Okay, now let us take one question. Krish from Mr. Deep Shah. What type of RCD protection to be made for steam and sauna for bathroom?
Okay, so Gerard, anything to add here?
Yeah, from our side, we would go for 10 milliamp RCCBs to have even better protection against electric shock. Normally, in Germany, you have a standard of 30 milliamp, but in different locations in the world, 10 milliamp is meanwhile prescribed. So 10 milliamp of residual current would be the safest version.
It depends on the type of sauna heater. I mean, so obviously, like you mentioned, the standard requires 30 milliampere. Same in India. I'll just share the screen as well.
The heater. Okay, sorry.
Yeah, but it depends on the type of heater because the rated current is fine. I mean, I'll just go here. See, National Electrical Code, full screen. Special locations. Here, requirements for special installations. Rooms and cabins containing sauna heaters is on page 442. So if I go to page 442, just a second. This provides requirements for sauna heaters. Now, these supplement and modify the general requirements of the standard. So, requirements for protection against electric shock, additional protection, here it says, additional protection shall be provided for all circuits of the sauna except the sauna heater by use of one or more residual current protective device. So, if it's a TN system, only every circuit except the heater requires RCD protection of 30 milliampere. If it's a TT system, then every circuit requires protection of RCD with RCD for 30 milliampere, except for sauna heater where you can use 100 or 300 milliampere as required. Now, when it comes to the type of RCD required, that depends entirely on the heater itself. What kind of a circuit is it? Is it a three-phase? See, sometimes in sauna heaters, you have electronic controls to set a temperature of the sauna inside. Now, this may be done with mostly the sauna heaters are three-phase. This may be done using some kind of a power supply with where it messes with the waveform to control the power. In that case, you have to go with a type B. If not, then and it is just multiple, one heating element, two heating element, three heating element, and as per the temperature setting, the heating elements turn on, then a type A is acceptable. But it really depends on the type of sauna heater and control mechanism. But on the safe side, type B.
Okay, right, Krish. Mr. Jackson, if you have any question, probably you can speak.
Good afternoon, sir. I am Jackson Sebastian from ISRO. I have two questions, sir. First question is there any standard method to test the RCCB at site? Second question is, what is the life of an RCCB? When to replace it? So for a critical application, can you answer on that?
Yeah, I will answer the first question regarding is there a standard way to test? Absolutely, there is a standard way to test. You have to get a test instrument that conforms to a particular standard. I will just show you. So if I just search for IEC 61557-6, this is the standard that talks about test equipment that can test an RCD. There are a variety of devices. If you go online and say RCD tester, don't go for all this small nonsense. Sorry, one more. RCD tester. A device like this, we don't know whether it actually conforms to standard. You need to see. An example is there's a company in India called Sonel. They make an RCD tester that actually complies to the standard. So, and 1 minute. See, RCD meters. Yeah. And then you have here, this particular device, it actually conforms to that standard. It will be mentioned in the data sheet, technical data, files to download, 1 minute. Data sheet. Yeah. 1 minute. Yeah. 61557. So only this device that actually meets the standard you can use to perform the test. If we look at the declaration of conformity, they will have that particular standard written there as well. This is in Polish, so yeah, here 61557-6. So only the RCD tester is for this, but is conforming to this particular standard, then you can use it to test. Regarding the first question, Gerard, would you like to answer the second question? What is the life of an RCD?
It's hard to say. As per the norm or the mechanical and electrical endurance, there are certain values. Mechanical endurance, I don't know, I think minimum 5,000 cycles. Electrical endurance is minimum 2,000 cycles, but it does not show you the real lifetime of an RCCB. So we have different series of RCCB out in the market who are 40 years old and they're still working. But it absolutely depends on the installation, on the application itself. Is the test button being used frequently or not? If you do not use the test button for 20 years, I think the RCCD will not work mechanically anymore. So it really depends on the application and on the breaker. So there is no certain lifetime in the norm yet. It is being discussed, but it's not yet, I would say.
Okay, sir. Thank you so much.
I'd say, see, you're required to perform periodic inspection and testing. When you perform periodic inspection and testing, you are required to do an RCD test. The test is done with a test button as well as the instrument that I showed you. So when you have a test instrument that it doesn't trip in the required time, then it's a failure to replace the RC.
Okay, right, Krish. We have 30 more questions, but most of the questions are already answered. So probably we can have 2 or 3 more questions. Mr. Ravi Devaya, Mr. Venkatesan Egambaram, and KD Kavaya. If you are there, you can speak.
Sir, I am Venkatesan. Are you audible, sir?
Yes, please.
Sir, any periodic time is required for 1 year. Every year is enough for testing, or any fault tripping. After fault tripping, it is required to testing with device.
Krish? The RCD tripping is the question.
So you mean the tripping time?
The tripping, the frequency of tripping, how frequently it has to be tripped? Is it after every fault, every tripping of the device, or every 1 year, or whatever?
I don't understand. Is it regarding the test or what is it?
Test.
Test has to be done as required in NEC. There are different intervals depending on the type of installation. Tripping time depends on the product standard. So for 61008, 61009 devices, when you test at I delta n, so for 30 milliampere, it should trip in lesser than 300 milliseconds. At times 5, so for 30 milliampere, that's 150 milliamperes, it should trip in less than 40 milliseconds. This information can be found in the product data sheet or the product standard.
Yes, actually, this information is there in NEC in part 1, section 17. This is very much there. There is a table and the frequency of testing is also given. Now we have Mr. Ravi Devaya and Kavaya, KD Kavaya. If you are there, you can ask the question. Or if, yes, Mr. Kavaya. Hello, you have to speak. Okay, no question. Now I would like to take one question from 23 plus questions which we have from Mr. Abhijit Limaye, our CWC member, the secretary from Pune chapter. If I have a thermal magnetic MCCB without earth fault protection, can add ELR plus CBCT to cover this? I have seen some specifiers justifying this. Okay, the question is, there is an MCCB without earth leakage or earth fault protection. Can I meet that requirement with a CBCT and an ELR?
Hello, sir. Hello, sir. Can you hear me?
One moment, please. One moment, please. First, let us answer this question. Krish?
Yeah. See, in different type of RCBs and RCDs.
Sir, we are answering another question. Come back to you in a moment, please.
Yeah, Krish, you can answer.
So See, this depends on one. See, it's a very good question. I'll just go back to the slide that Gerard has shared. I'll share a screen. See, when you have an MCCB without a tripping characteristics of in earth leakage, you need to use what is called an MRCD. Now, you cannot just use any ELR with CBCT, and you cannot use an RCM either. The device, the CBCT and the relay together has to conform to Annex M of ISIC 64947 Part 2. Only and only then can you use it for protection against for earthfall protection. Otherwise, if it is some generic ELR, if it is a RCM, residual current monitoring device, that device cannot be used for protection. Which is why this standard ISIC 647 Part 2 comes, and specifically products designed for protection are manufactured under this standard. Only these products can be used.
Okay, now Mr. Kavaya, you can ask.
Yeah, sir. The thing is, different type of RCCBs, RCDs. People are confused which RCB is to be installed to the consumer, because when we go for the safety audit or some consultancy, there are a lot of things which you mention in your details. So not as per the IEC or IS, if you can prepare one standard question form in which a consumer will fill up all the things, and based on that, yeah, you can suggest, yeah, this will be the rightly and correct device to be installed, because existing plant, existing industries, they've got different type of things, ELCB, this and that. So we would like to have some format like this thing. Based on this, one can easily find out which are they can minimize the options.
Actually, this information is available in almost all manufacturers' catalog. It is also available in National Electrical Code, and this is available in multiple places. So, Mr. Gerard, you would like to answer this? The question is in order to select a different type of RCDs like type A, AC, and all. Do you have a selection chart?
For us, for example, we have a quick search selection tool, also combined with a guide where you get some questions to your application and to the load, and in the end, it shows you a small selection of RCDs being suitable technically for that. If it refers to your national standards, of course, I cannot tell at the moment. To the IEC standards, our guide would fit on the website, and I think loads of manufacturers do the same, as you said.
I'm talking for useful in India only.
Actually, some of the documents which we made, NFE made and circulated, which is also available on the public domain. We did this as some posters and circulated few months back. Also, in all our programs, this is again the presentations which we circulate. This specific slide or this specific selection is given. Also, it is there in the NEC. Anyway, we can try circulating this again. Thank you for.
Okay, thank you.
So, Krish, you are showing something?
Yeah, this is Gerard's selection chart that he was talking about.
Yeah.
Gerard, would you like to talk about this? Yeah.
So we have a selection chart on a black and white version. This is also being printed sometimes, but we have this also on the website. You have the same selection chart on the website. You can put in your values, and it goes through with you to the different breakers and to the right breaker for the right application. So this one could be placed on your desk in black and white. But if you need any checkup on the net, also there's a link where you can check for those special breakers. Selection guide. Yeah.
Okay, thank you. It's already 1 o'clock. We spent almost 2 hours, and with a very good participation. So many questions are still there, but I would like to ask one last question, which I took from out of maybe 30 questions, which is still to be answered. Also, we allowed Mr. Ravi to talk, but he's still silent. The question is, does anybody make IoT-enabled RCCBs? You see, this IoT is becoming a very fancy subject in India. Next week, we are going to have the webinar, which is on IoT-enabled, protective device. In India, it's very funny that somebody advertises that I have a IoT-enabled device, and what it does is it measures the unsafe situation and it sends you a message.
Okay.
So that means in your house, your probably one of the electrical appliance is in trouble, and you will get a message saying that your equipment is in trouble. But the problem is if somebody touches the message, if somebody touches the equipment and dies, there is no guarantee. Also, if you are touching the machine and if your mobile phone is in the pocket, by the time you get the message, you are already over. So without understanding the basics, people are trying to sell products without any fundamental ideas. So we are going to have a webinar on next week, Saturday, the same time on IoT based device. Probably the few questions I can see in IoT based device. So please participate in the next week program. We will explain what exactly it is. Krish, you would like to answer something? You have to unmute. Yeah.
Gerard, would you like about this device?
I can. Thank you for sharing. As Mr. Kumar as well explained it, it is the way how you treat the information. If you take it as the only information and you do not know what is in the background, what the basics are meant for, then the information may not have any effect or do not help to protect you, but it can give you additional informations. So those monitoring devices which are existing on the market. You see here our eGuard monitoring system, so we can monitor residual current. It is also being connected via PoE to your net and can give you informations and a text on your cell phone or on your system that something is wrong in the system and that problems are arising and are getting bigger, or even if something has tripped. But in the end, of course, you have to know what you're doing and have to be prepared that nobody is affected by it. But additional information is getting more important and more important. So visualize different data is one of the topics we have in mind as well. So I'm pretty sure all the devices in the future, everybody will reclaim them as being smart. If it makes sense all the time, it's a different thing. But it will come more and more, I'm definitely sure.
Yes, you see, these devices can be used as to monitor some function, but they are not recognized as a safety measure.
Nope.
Because safety measure means it should disconnect.
It is.
Yes, but what happens is these informative devices are sold in the market as protective device, and they are being sometimes promoted even by the government agencies without understanding the fundamentals of electrical safety. So that is actually a serious subject. So probably it's time to stop, make an end to today's webinar. We already passed more than 2 hours. We have a few more people raised their hand. I'm so sorry that we are unable to accommodate you. We will probably try to make one more webinar maybe in next few months so that we can continue this particular discussion. We also have 30 plus questions to be answered. As the time doesn't permit, we can try to take it up in the next webinars. But most of the questions are already answered, and the questions which are pending are repetitive in nature. So thank you very much, Krish and Mr. Gerard, to participate in this NFE webinar. To become a member in NFE, participants can go to our website. There is a link, become a member. It's the cost of membership is very, very small. It's 1,770 rupees, including GST for the first time, and the second time onwards, it's 1,000 rupees plus taxes, the GST. So if you are a member, now we are preparing a lot of documents, and all these documents will be available for the members to access. Earlier, we were putting all the documents in the public domain, but now we are slowly making it members only, including the videos will be members only. So we request you to become a member of NFE. It's a society for personals, people, those who are participating in electrical safety. So finally, Mr. Gerard, you would like to have any comments, any opinion about the webinar to the participants?
Yeah, it was very interesting for me to see also the dimension of how many experts were taking place in this webinar. It was very well organized from you three guys with Dominic together, and very impressive, really very impressive. And yeah, if it makes sense for us to participate again, also perhaps a colleague of mine, please feel free to invite us or give us the chance for it. If there are any questions related to special RCCB topics, my contact data is given. Please transfer it to us. We can answer it inside the company. You will get an information if we can. Thank you very much for the time. Thank you very much for the possibility.
Thank you, Mr. Gerard. Mr. Krish, you would like to have a small chat? Or
I'd say quite interesting to see that people are asking more of the right questions. We have not had any questions about earth electrodes and neutral to earth voltage today, which is showing that people are getting their heads more in the right space. So everything NFE is doing, talking about standardization, it's going somewhere. So that's a very nice thing to see. Yeah, thanks. And
yes.
Thank you, Gerard. Wonderful presentation.
Thank you, Gerard, for this wonderful presentation and spending 2 hours with us and answering all the questions. So participants, next week, as I explained, we have another interesting webinar on IoT-based device. It is not about the communication, but it is about a specific device which is falsely promoted as a safety measure. We will discuss more on it. Then on the future, the week after, we have a webinar on lightning protection, then another on data centers and so on. So wait for more and more information, technical information from us. We are constantly working on it. So with this, we would like to end the program. Thank you very much. Thanks for all the participants and the speakers. Thank you very much. Lakshmi, you can close the program.
Sir, you have to end the session, sir. You're the host.
Okay. Thank you. Bye-bye.